I will kick it off to our first session, which is intelligent supply chains. To talk about intelligent supply chain, we have Rahul Patel, who is the Senior Vice President and General Manager of Connectivity, Cloud and Networking at Qualcomm Technologies. Rahul will be in conversation with Bob O'Donnell, who is the President, Founder, and Chief Analyst at Tech Analysis Research, a technology market research and consulting firm. So take it away, Rahul and Bob.
Well, good morning, everybody. So, obviously, supply chain has been a hot topic, and when we think about what's been happening with the supply chain during the pandemic, we learned a lot of things, right? Everybody learned a lot about what's going on with the pandemic, or with the supply chain during the pandemic. But before I get into that, I realized I forgot to do the introductions. I'm sorry. My name is Bob O'Donnell. As you heard, I'm the President and Chief Analyst at Tech Analysis Research. I've been a tech industry analyst for over 20 years, working with a variety of big tech companies. I also write for USA Today and Forbes and Seeking Alpha and other places, and do a lot of video for the business financial networks. And joined, of course, by Mr. Rahul Patel. Please.
Good morning, everybody. Thank you, Bob, for the introduction. As you said, and as I was introduced, nothing has changed since. I'm still Rahul Patel. I am Senior Vice President, General Manager for Qualcomm, and I look forward to this conversation.
Yeah. So anyway, back to what I was starting to say. You know, during the pandemic, one of the things that really became obvious was how dependent the world was on semiconductors, right? From cars to washing machines to everything. Obviously, all the PCs and smartphones that were sold during that time were a big deal, but people didn't understand how big of a market it was, how many companies were involved, how many products they used every day were influenced by that. And there was some, big wake-up calls, and I think we've all seen stories in the general press about what happened with that. Medical devices as well. And what we also learned is how fragile that semiconductor supply chain is and how challenging it is to maintain that. So I want to start things off. Qualcomm is obviously one of the largest players in the semiconductor business. So why don't you give us a sense of, what did Qualcomm do during the pandemic? What have you learned? How do you see yourselves applying some of those learnings moving forward?
Excellent question. Clearly, there was the movement towards cloud economy. There was this movement towards digitization of everything that we did. There was this movement of social networking. But with COVID, everything accelerated at a pace that nobody had anticipated. Nobody had thought we needed to be prepared as wild the ride was for everybody in the tech world. And semiconductor definitely got tested from supply chain point of view in a major way. As you know, semiconductor investments take time to bear fruit. It is building out massive factories. It's not like writing software code. I'm not trivializing writing software code, but it is building out massive factories. It is putting together massive capital so that CapEx can be deployed. And it is also fine-tuning the factories so that you can deliver the goods that you're supposed to deliver. And so all that said, Qualcomm being the largest fabless semiconductor company in terms of the total amount of output it sources from all these factories, we were in the middle of a massive supply chain crisis. Everybody wanted to work from home, which we knew, we were working from home, but not with the same intensity that came about with COVID. Everybody wanted to school from home. That was a new dimension. And everybody also wanted to play from home, right? And so that drove another level of dimension of connectivity, compute, and all kinds of other things that needed. And so as Qualcomm, many people say we are the Vatican of wireless communications or Mecca of wireless communication, a center of gravity for wireless communications. Everything that needed to be done from the home was largely untethered to any other device. It was all wireless communication, be it 5G connected mobile phones, or be it Wi-Fi connected devices, or be it computing in the cloud or at the edge. And so all of a sudden there was a massive surge, and it was not just Qualcomm but everybody else, but the tax that it created as a result on the supply chain was clearly to a place and time where it could not withstand the surge in demand. And so we all kind of experienced the first year of COVID as being a very, very wild ride. Fortunately, what Qualcomm had put in place worked extremely well. We were able to multi-source very quickly and get going in the right direction. But lead times on our products went from something that was around 15 weeks to, in some situations, excess of 52 weeks. And that, again, created a lot of problems for everything that needed to happen during COVID, which is working from home, schooling from home, playing from home, socializing from home. Not all was possible at a quick instance like everybody thought it would be during the time of the pandemic. And so a lot of things were learned along the way. A lot of improvements have been made along the way. And I think the semiconductor supply chain is working through some of these issues even today.
Yeah, no, exactly. And of course, obviously, as we've seen many other times, just not quite as dramatically, the classic, bust, boom, or boom, bust, and we're still obviously going through that. But why don't you give a few examples, if you can, of some of the things you specifically did to help address those issues from a supply chain perspective? You talked about multi-source. I think a lot of people don't realize that, yeah, Qualcomm actually, you're getting chips, I know, from multiple places. There are a few foundries here in the US. Not too many people know that, but there actually are. And I know you work with several of them, Global Foundries amongst others. But what are some of the examples you can give of companies you worked with and what you guys did to help deal with some of those issues?
Yeah, I think with limited capacity in the semiconductor world at that time, and being in the middle of this massive storm of demand, also being mindful of the fact that we were the largest sourcer of semiconductor manufacturing in the world before the pandemic. And so finding a way to multi-source in that equations or constraints was massive challenging proposition for Qualcomm. Effectively, we had to figure out how we are going to double the capacity. This is on the largest fab sourcing company, largest packaging test sourcing company. And so it was a massive challenge on hand, number one. Number two, during this time, there came about the dimension of geopolitics and the need to diversify geographically the supply chain. That added additional constraint to the mix. And then obviously there was the war in Eastern Europe and Russia that added a third level of complexity. Again, none of this was anticipated. None of this could have been planned for. And as I said, it's a very capital intensive marketplace. And so if you have to deploy billions and billions of dollars, you have to be mindful of what you're going to get at the end. And so like Bob, you indicated, there's a boom and there's a bust as well in semiconductor industry. And so a lot of these constraints were needed to be kept in perspective while the need for diversity of supply was being sorted out. And as Qualcomm, we have this need in our engineering where two recipes, I'm using the words very loosely, recipes from two different manufacturing sources or fabs is never the same unless they license each other's technology, which is very difficult to happen these days in the marketplace. So given that the two recipes, the basic transistor upon which the design's based is never the same, Qualcomm effectively does grounds-up design engineering on the library that it builds on its own that works across multiple recipes in a similar process geometry. And so we had that fortitude, we had that ability in place where we would be able to design in one fab and able to also do a similar design very quickly in another fab and have the same, manufacturing outcome come into play. But effectively, it had to be going through, a cycle. It's just like anything else. It takes 9 months to make a baby. You can't shortchange that. And this, manufacturing with semiconductor is no different, right? And so I just wanted to put things in perspective. We had to have those lead times, and on top of that, the demand navigation, because of the supply constraint, added additional constraint. So long story short, there were methods put in place. We took charge of a lot of places, capital intensive investments were made on behalf of our suppliers. We work with our suppliers to invest in their factories. This way they would not be on their own should there be a boom and followed by a bust, right? And so a lot of strategies were put in place. Also, in this time, given the geopolitical situation, semiconductors' importance to the economy, as we all transition to the digital economy, was just phenomenal. And so this bubbled up to the governments around the world and became a massive issue given the geopolitical backdrop, the war situation, the need for keeping supply intact, and also protecting the IP, which is the designs of the chips that are getting built, was at the forefront of the government's minds. And so governments had to get involved, and geodiversity was at the forefront. So a lot of things were worked out, and I think, like I said, there's a gestation period in how we get well, and I believe we are almost 3/4 through that way, and a couple of years we'll be in a better place.
Yeah, and since you brought up the geopolitical diversity, obviously we have the CHIPS Act here in the U.S. That we were hoping is going to make a big difference. Of course, there's debate now because it's like, oh, wait, why do we have to build this new capacity when right now there's a lot of extra supply? But, I think, again, the problem is we've got too many people thinking short term because, as you've said, we've moved to a new world where everything is digitized, everything is connected, and all those demands are going to continue to grow over time. So, of course, there's going to have to be capacity. But in the near term, it's a little bit messier. But I am curious, so we've got the U.S. CHIPS Act. I'm curious for Qualcomm's take there. Obviously, we have a lot of folks from India or connections to India here. Do you see anything happening there, perhaps, on the semi-manufacturing side? What's your perspective on all that?
Yeah, I think the U.S. CHIPS Act is a big step in the right direction, but I think more steps have to be taken in that direction by the U.S. government. So I'm not complaining, but I'm looking forward to even more bigger investments. Geodiversity is definitely a key topic. Today, from Qualcomm's perspective, we source, give or take, some 20% of our silicon in North America. Comes out of, obviously, you mentioned Global Foundries in New York, and also the Samsung fab in Austin. Right. We are hoping with the investments TSMC is making and Intel's making in Arizona and Ohio, respectively, there'll be more supply becoming available. I know it's going to be another couple of years before we see something bear fruit in those investments. But long story short, we are sourcing, I would say, almost 100% of our finer process geometry products, sub 10 nanometer, I would say, or 7 nanometer and below, or finer process geometry, out of Pacific Rim, basically, largely two countries, Taiwan and South Korea. It's a lot of supply from one region. Semiconductor industry has been prone to other natural disasters in the past. Those regions are regions where there's a lot of seismic activities going on. Earthquakes have been a problem in the past. Fires have been a problem in the past. And so keeping those dimensions in mind, and with the newer situation that we have between the countries of United States and China, the sourcing from China is always now kind of a challenging thought, given we don't know where we would end up, hopefully in a better place. But long story short, I think these are some of the challenges. And so, like you said, I think a lot of, the brain trust in the semiconductor industry is also coming out of India. And Indian government has shown appetite. There's some private companies showing appetite of investing in fabs. I believe there's a commitment been made. Hopefully, we see more of that coming together. And I believe investments like that are needed. Today, you have fabrication in Taiwan, majority of it in the finer process geometry, but there's also in South Korea with Samsung. There's in North America, Austin, New York. There's some in Germany. There's some in Israel. And so, more diversity is better. And, India definitely is a place where, additional fab capacity would do good to the world, basically.
It would certainly make sense, especially given how much growth we're seeing in India around, tech-related products and what have you. Let's talk a little bit about some of the big picture trends that you see continue driving demand in the semi space, particularly around connectivity. We talked a little bit about it, but we haven't even mentioned 5G yet, right? 5G is out there. And the interesting thing about 5G is also enabling new types of connectivity like fixed wireless access, which is a huge opportunity to leverage cellular networks in a way we never thought of before, and tying it to Wi-Fi, which I know is near and dear to your heart. So just curious for some of your take on some of those big picture trends.
I think I'll put things in perspective first. I think about 10 years back, we all carried a cell phone. The cell phone had about probably 50 odd chips in there. Today we are packing a lot more transistors in every silicon that we have, probably an exponentially lot more number of transistors. There are give or take 170 chips right now. So we have tripled the chip count basically in a cell phone. 5G has driven use cases that are beyond cell phones. Cell phones definitely, I think around the world we have a lot of 5G being deployed, and the ability to get the experiences over wireless networks that would be otherwise needing some kind of tethering or some wired network is just phenomenal with 5G. The world is changing. My understanding is by 2027, 25% of the world's cars would be EV. We are going from cars with some Bluetooth, something in the dashboard, some Wi-Fi, to a place where there's going to be 3,000 chips in a car in 2025, 2026 time period, and 25% of those cars basically would be digitized, have at least a level 1 or more autonomy in it. And so you look at the equations from everything that we do has evolved dramatically in terms of the content it is sourcing from the semiconductor world. You brought up Wi-Fi. It's something that's everywhere now. It's we've given up Ethernet on our desktops. We've given up Ethernet phones, wired phones. It's all Wi-Fi connected. We as Qualcomm, we've shipped over 6.5 billion Wi-Fi radios in the last 5-6 years. So we are at a clip rate of about 1 billion Wi-Fi radios a year. And you can see where this is all going. Wireless communication is going to be essential to our lives on a going forward basis. You can see the cloud economy. Everything that we do through our apps, it's all connected in the cloud. Everything that we do, even at work now, it's all in the cloud. So the compute dimension is growing dramatically in the cloud. And so the amount of semiconductor that's getting used in the cloud is just phenomenal. Fixed wireless access, something you mentioned, broadband in the world is extremely valuable and important to people's lives. I would say it's the most important utility in many homes today. Homework doesn't get done, work doesn't get done, people don't get entertained if you don't have broadband communication. There's a wide broadband, but then there is the extensibility that's needed for broadband where it is CapEx intensive. It does not make sense to extend the fiber in some remote parts of the world, and that's where you have wireless broadband, which is where fixed wireless access with 5G comes to play. And so I can go on, and the larger point is, if you look at the world we are in, semiconductor is the new oil. The world is going to be dependent on semiconductor like never before. Like we were dependent on oil maybe 40, 50 years ago, and for the last couple of decades. I think we are moving away from the dependency on oil, but the dependency on semiconductor is just tremendous. And so you see the importance and the growth of the need for having resiliency in the supply chain for semiconductor, the diversity, the investments that's needed in semiconductor is just phenomenal.
And the other interesting thing is, it's interesting to hear what Qualcomm has done on their own supply chain, but as you were starting to point out, some of the Qualcomm technology is also able to be used for other companies to make their supply chain smarter, right? The whole notion of tracking shipments more closely. There's so many places where the connectivity solutions that you guys enable are being used to make smarter supply chains. So I'm curious, and you guys even just announced a new platform called Aware, an IoT-based platform designed to leverage some of that specifically for supply chain manufacturing. So curious to hear a little bit more about that.
Excellent question again, Bob. I think the big thing is, technology is great if it is presented in the right user interface, right? Technology is very complex to deploy. It takes time, it's expensive to deploy. And so from a Qualcomm perspective, I'll come back to the supply chain dimension. I think we've taken a different approach on deploying technology. We've gone from being a chip company, a modem company, building systems solutions, to now being software first. The user experience, how this thing from a technology and system point of view gets deployed, what is the time to market equation, what is the manageability of that technology in the field equation going to look like. They all require software-first approach, and that's where we have gone. So recently we announced our latest and greatest IoT platform, which is a software platform. It's about managing IoT devices from the cloud. It's called Aware, so if you get a chance, please do look up. It is a platform from where the manageability of products is much easier. Its deployment is much easier, and knowing a little bit more about everything that's going on in the supply chain, it becomes a lot easier. For example, today the retail channels are getting to a place where wirelessly they would be communicating directly to the supplier in terms of what kind of goods need to be replenished, all the way from the product that's facing or the shelf that is facing the consumer to back to the warehouse. There will be instant communications through the cloud and wireless communication. And I think these are the logistics and supply chain management areas where companies like Qualcomm play a huge role in making sure the right aspects of supply chain, time to market, just-in-time supply is made available and effectively deliver an experience that's good for everybody in the ecosystem, from the consumer to the supplier.
Yeah, and of course the thing about those technologies is they have value well beyond tech, right? Whether I'm shipping bottles of Coca-Cola or anything, all of these types of industries are starting to leverage some of these technologies. So I'm looking at the clock, trying to be sensitive to time. So let's kind of look forward. Where do you see some of these things going? I mean, look, and just to play devil's advocate a little bit, we've been hearing about IoT for a long time, let's be honest, right? I mean, there's been a lot of discussion, and we haven't always seen some of those things play out the way we initially thought or hoped might happen. So how do you see it being different now? What do you see changing? How is all of this moving forward? And how can companies benefit from some of those types of changes?
Yeah, I think the buzzword these days is AI. Right?
That's for sure.
But if you kind of double click on the word AI, it is all about connectivity and compute, right? And compute in a way that helps you garner intelligent decisions that otherwise would take a lot of time to get to. And so that is where everything is going to go. So if you are able to provide the best-in-class connectivity so that, if you're computing in the cloud, or you have a hybrid compute which is split between the cloud and the edge, your cell phone or your PC or your gaming console or your TV is able to compute a bit and then some more in the cloud, I think that is the architecture that's going to go about. At the end of the day, I think we in Silicon Valley and maybe in some parts of the country, in India like Bangalore, we may be unable to understand AI, but if I talk to my mom, she gets nervous, if not scared, right, with some of these concepts. And so I think it's all about how do you present some of these aspects to the average consumer in a way that it improves their lives without compromising certain basic aspects of lives like privacy, security, and give them an experience that they will be more than happy to embrace and take it to a newer level, right, in terms of their livelihood and productivity in life. So I think those are the aspects that we really want to kind of go down with. If you look at, if I talk about some things, if you look at our homes, right, for example, about 2 decades back, maybe I had a Wi-Fi router, maybe I had a PC with a Wi-Fi connectivity, maybe a phone with a Bluetooth, right? Today, in my home, there are 40 Wi-Fi devices hanging around somewhere or other, right? Maybe I'm a case that is an exception, but the research says in the United States today there are give or take some 15 to 20 devices in a home where a family of 4 resides, where it is connected to the Wi-Fi access point. If you look at that equation, you have Wi-Fi mesh coming into the home. You see exactly what is happening in the enterprise where an IT manager is managing that enterprise network. Effectively, that level of complexity, that level of security, that level of manageability is going to be needed in the home. Expecting my mom to manage that is unreal, right? If anything, she's going to throw that equipment into the garbage can, right? I would be lucky if she didn't do that. So again, going back to software first, user experience first approach while deploying complex solutions and systems is going to be very valuable. And that's where Qualcomm is going, and I'm hoping the rest of the industry goes.
Yeah, no, I think you're absolutely right. That idea of simplifying by leveraging smart AI that works in the background invisibly, but just makes the experience of using everything so much better. So, all right, well, on that note, being sensitive to time, I think we're right at time. Thank you so much, Rahul, for the conversation. Really appreciate it.
Thank you, Bob.
And thanks for attending.
Thank you, everybody.